So, moin! This video is part of the Scientific Python lecture course at the University of Bremen. And in this session we would like to deal a little bit with the I/O of Python, so how we can read and write files in Python, especially text files. As always, we will follow the lecture and the slides as they are given on the website, so you remember you can just download the slides for each of the exercises and on each of the lectures from this URL here. And before we start, so we will basically in this session do file I/O, and in the next session we will just deal with the basics of how to plot in Python using the matplotlib package. In order to do all those things, especially the plotting, we will need to install two new packages, the Python3 SciPy and the Python3 matplotlib packages, which we can just do with the usual way, sudo and then apt get or apt, doesn't matter, and then we install. And then I would like to install the Python3 SciPy package and the Python3 matplotlib package. So as you remember, you will have to provide your password to get super user access, and then basically we just download the packages and let Python install it. Once the installation is done, we can basically start our IPython notebook or Jupyter notebook where we carry out the exercises. So basically the installing goes quite fast. It's on the stage of unpacking it, as you can see, and once everything has been unpacked, it will be installed. In the meantime, we can already have a look at what we were dealing with today, and it's the file I/O. So basically the purpose of this exercise is to read in data from files, which is very common also in scientific programming. Some other program has created a file with the data you would like to analyze, and then of course you have to read in this data into Python, especially in an array. It's usually a numerical data, and then you want to process it at some point. And basically this necessary step of this reading we will just demonstrate and learn today. So let's start. The installation has finished. Let's start our Jupyter notebook as usual. And because we will need some files, I will now make a directory, let's say work. I will just go to work and I will just start the Jupyter notebook from here. And we will also need another shell where we can edit files. So I will just with Control Shift T make another tab in which will be open in the same directory. Okay, so Jupyter notebook, just going with Control page up and page down. I can just switch between the two tabs in the terminal window. It's also quite handy. And now in the one window I will just start a Jupyter notebook, which will start the browser, of course. And once the browser is started, we can with the usual way open a new Python worksheet. Let's do that. If you go to new, just to remind you, and Python3, and then a new Jupyter notebook is opened, and then here basically we will just give it a name, so it's not named untitled, so let's just call it file I/O and then rename it. Okay, good. Going back to the slides. What do we need? We need to read a file, and I would like to demonstrate this reading. But first, then we would have to create the file so that we have some content we can read in. So let's basically change back to the command line window and now to the second tab. And you remember we have learned leafpad as one possible editor if you don't know any other to open a file, and let's call it test.txt. So we will just create a kind of text file. And the content can be something very easy. This is line 1, here is line 2, this one should be line 3, followed by line 4. That should be enough. So I will just save it with Ctrl S, just save it, and then I will just with Ctrl Q basically leave the editor. And if you see here, indeed, now in this directory I have two files. I have the file I/O, IPython notebook or Jupyter notebook, and here I have this test.txt file which I just created. By the way, if you want to have a look at the content of test.txt, there is a Python shell command for that. It's called cat concatenating, Concatenating means just appending to each other. So for example, if you would just say test.txt and once again test.txt, it would be a file which is where the content of the two has been concatenated. But of course, the nice thing is if you just use it with the file name once, then it exactly shows you the content of the file, and then you see this is exactly what we have typed in. So far so good. Now let's read this thing in Python. So basically let's change to our IPython notebook, and one of the possibilities to read it in, as demonstrated on the slides, is just basically with the open the way to do it is the open command, and the command syntax is you are just setting up a variable which will contain the file representation, the file pointer, if you are coming from another language, or the file handler, and then you are just specifying the name of the file, and then you have to specify how to open it. We will just deal with the different ways how you can open a file. Here we just specify R, which means we only want to read the file but not write the file. And if you execute that, the file has been opened. And now you can just basically tell Python what to do with the open file, and one possibility is just to read in. So we can just a text, and then it should be fp.read. So basically it means the file handler, the file pointer, please read in the content. And once you have finished with that and you don't want to manipulate the file anymore, at some point you should close it, right? That means after that you cannot execute, you cannot execute any operations on the file anymore. If you do that, you get an error. So closing means, okay, all operation with the file has been finished, and that's a good practice to close the file as soon as you don't need it. We have here made txt is equal fp.read, so let's just execute it again. Reading, opening, reading, and closing, and then if you know, just basically print out the content of txt, then you see this is exactly what was in the file. By the way, if you want to compare it with the content of the file, one possibility is of course to look up what we got with the cat command here, but I will show you a trick how you can do it also in the Jupyter notebook. And there's this magic command which are starting with percentage, and one of those commands is cat, exactly as in the shell, and then you say, okay, I want to basically get the content of test.txt. You see even the tabulator expansion works automatically. It will be executed, and you see now you get exactly the content of that file. So basically you can also compare this way, and it seems to be exactly the same. Okay, here you see I told you must open the file, do something, and closing it. And sometimes it's not that nice to do it by hand, and you can automatize it, this closing procedure, especially if the block which is longer what you have to do with the file while it is open, and if you want to make sure that the file is closed, it doesn't matter how you leave this block which deals with the file, then you can use the so-called wit command, and then basically you say the same thing as before. We are opening test.txt in read mode, and we say the result should be stored as fp, and now we are opening a block, and basically within this block the result of this command will be stored in this, or assigned with this variable. And then basically here we are just txt is equal fp.read, and if you execute it, the same thing happens as before. So txt is again just the right content. The only difference is that here I didn't write a close command, and the reason for that is this is a so-called context block or a context manager, which means it opens the file, stores the result, or assigns the variable fp with the file object, and basically this with construct makes sure that as soon as you are leaving this block, which is the sub block of with, it doesn't matter which way, because you stop the program, you are just jumping out or whatever happens, as soon as you leave this block, the file will be automatically closed, so you don't have to close it by hand. So that's also another strategy how you can read and close the file. And also as the example demonstrates here, as soon as you are out of the block, so you leave this sub block, then Python will automatically close the file. Okay. And we have said that there are different ways how you can open the file. We were using the R command, the R flag, which is for reading, and that's the default one basically, which is usually used. But we could have also specified the W. We will see later if we want to write files, then the W would be the right option. You can also append to a file. What is the difference between writing and appending? Writing would basically overwrite the file, right? So let's try that. Maybe we can just make a test. If we are saying with open and test.txt, and now I'm writing a W as fp, so I'm writing it, and then I'd say fp.write something, and that's it. And now I'm just executing it. And now if we are looking at the command of at the content of test.txt, then basically it's not that what it has been before, but basically it's the new content. So basically it was overwriting it. Now if we are doing it with append something too, I will just append it, and then you see that it was appended. Okay, there's no new line in between because we didn't write it. We will come to that in a second, but basically you see that A would append to a file. So you have to be very careful if you are using W, then if the file was there, it will be just simply overwritten. So that's, you have to be careful. Otherwise, another flag you can specify is the B for the binary mode. This we won't deal with here at the moment, but if you want to deal with binary files, non-text files, then that's the right thing to do. Text mode is for T, but this is a default. We didn't specify any mode, so therefore we got also text mode, and there is no also the option plus, which basically where you can read and write the same file under certain conditions for updating. Now let's go back to the reading, and for that maybe I would like again just to get the content back as it was before. So I will basically just mark the things here which we had with the cat. I will with Control Shift and C copy the contents instead of Control C, Control Shift C, because in the shell window the Control C is reserved for breaking or for stopping a running program. So therefore you have to add a shift. So Control Shift C, I have copied it. Now I'm just opening leafpad with leafpad test.txt, and of course it's the wrong content, but with Control V I can just now basically insert what I have marked before, and then I'm just saving it again. And then with Control Q I'm just leaving it. So basically now if we look at the content of test.txt, then it's the old content which I want to manipulate. And basically now, usually if you read in this content, usually you want to deal with that, not always, but very often you want to deal with that line by line, right? So we are processing very often data which is stored line by line. The way we have done it before, so far we were saying, okay, we can just do it with the construct open test.txt, and we were using the read mode fp, and then we say just txt is equal to fp to read, right? And then we could just get txt is this one. Now if we wanted to deal basically just process it line by line, we would have to split the text, let's say just normally with the split command, which you know already know, the split method of a string, which you know, but the problem with that, it will split by any white spaces, so it's not necessarily, I would get it word wise, not line wise. If you want to make sure it's split by lines, then basically you have to specify the splitting character. \n, you remember, is the new line, so basically this is the way how you could split it by a new line, and then you get each line separately. And because at the end of the last line there was a new line, therefore basically you get at the end one more entry with the empty string at the end. Okay. Right, so far so good. But this is not always the best method to deal with that, especially if the file is very big. Then it could happen that you don't want to read it at once, everything, but only really one line, and then when you process it, you want to read the second line, and that's a very good strategy for very big files. And therefore Python also offers other ways to read the file piece by piece, and this is what we want to have a look at. So if you look at the slides here, I'm showing a few other way of doing it, and the first one is just looping over the file. And if you make a for loop over an open file, then basically what you get is exactly the content of the file one by one. So this is a very elegant method. You have to open the file though first. For example, we could just use this with open test.txt, this context manager, as fp, which makes sure that the file is closed. And now we could say, we could just make a for loop for line in fp, and then we are just printing it. We will just say, okay, print, we will just print the word line and then the content of the line. And you see what happens here is indeed it is printed every line is printed once. Okay, so basically if you make the loop over the lines, then basically you get the single line in one iteration of the loop. If we have a look at the line at the last value of the variable line, which was basically the last time this cycle, this for loop has been passed, then you see that basically this is exactly the content of the last line, but it also contains the new line character. So this is something you should be aware, that here, in contrast to the method here before where we split it and the new line characters were removed, here if you are looping over the file, you get the full line including the new line character. You can also, so this is a very nice method if you don't want to read everything. If you want to read everything at once, but also line-wise without splitting it, then you can do it. You can do it also with the read lines method. The read lines method would basically work. You say, okay, lines is equal fp dot read lines, and this is something you do it once, and then you can close the file, and then we can just print the content of lines. And you see again, you get a list with the lines. Every entry contains, of course, still the \n character, the new line character. So that's a very nice method if you want to get it line wise and but reading it at once. Okay. Otherwise, for example, if you don't know how long, whether you want to read everything or not, sometimes happen you are just starting to analyze the content of a file, and then depending on the condition, what is in the file, maybe you read it, maybe you don't read it, maybe you just skip some blocks, then you can do it with a while loop. So basically you are reading the file again line by line, but you decide whether you want to finish reading or not, and for that the line method, the read line method is good, which gives you one line of a file, and then if you call it again, it gives you the next line and the next line and the next line. So also one possibility is that basically we are opening the file first. Now I will just open it the other way just to demonstrate that this works as well, and then we would say, okay, our line is just fp.readLine, so we are reading the first line, and then we are making a while loop, and the while loop, as you see on the slides, goes basically on line. What does it mean? The while loop runs as long as the read line command was returning a non-empty line, so basically a line which has any content, and then we can just print the content of this line just to do something with that. And then otherwise then we would need to read the next line in order to avoid to have an infinite loop. So basically we are associating then the variable line with the next line of the file, and then basically this would run as long as the line is non-empty. And basically once a non-empty line has been returned, that means the file is basically the end of the file has been reached. Basically that was stop. Empty line means that the line does not even contain the \n, the new line character at the end, right? So if you have in the file an empty line but not the end of the file, then that this approach would still work. Let's have a quick look at that. We can just with leafpad edit test.txt, and just here we are adding just an empty line between the line 2 and 3. Just to demonstrate that, I have just saved that, and now if we are executing this here, you see it's still running. Okay, it will be the empty line, but it contains the \n as a character. So it's non-empty. So basically in this Boolean expression, it's evaluated as true. But then when we reach the end of the file, so usually we get the empty string without the new line character back, then this will stop. Okay, so that's also one way to do that. And then finally, the way which we demonstrated already, you can just read everything at once. Okay. The other way around, if we want to write things, then basically this is very similar. We have to open the file but with a W flag, and then we have to use the write command, as we have seen already, to write content into a file. The write command, which we have, as we have seen it also before, so let's demonstrate that. We are opening, so for example, test2.txt, and then we are opening it in write mode, and then now we just can start and write things. Let's say write line 1 into this, and then we will also close it. Okay, and now if we are just showing the content of test2.txt, you see I didn't even have to specify the quotes. Then the content is line 1. What was this 6 which was returned by the fp.write? Is a number of characters which has been written. Now if you want to write multiple lines, this is something you have to keep in mind. Let's say we are also writing line 2, and then it doesn't work, of course, because I didn't open the file first. The file has been closed before, so you have to open it, then make the write commands and close it again. And then you see if we are showing the content of test2.txt, you see that there is no new line character between the lines, because the write command does not add a new line character. So if you want to do that, you have to do it by hand. So basically you have to write strings into the file which contain it. Of course, I made again the mistake not to open the file first, so don't forget, open the file first, then you can execute it, and then you can close it. You see that the number of characters which last write statement was returning is 7, not 6 as before, because of course the additional new line character was added. This is a \n is 1 character, 1 new line character. Okay, let's close the file just to be on the safe side. And then now if you look at the content, you see that basically you have properly new lines as we usually would expect. And even if you would look, for example, here, of course, on test2.txt, you get, of course, exactly the same content. Or if you would open it in LeafPad, you would get, of course, the same content. Okay, and that's basically is from the writing. You can, of course, as you can read line-wise, you can also write line-wise. So basically you could have a list containing the lines and then just write it. So we could just say, okay, or list lines is line 1 and line 2 \n, and then we could just okay, let's just do it here. We could just open the file. Let's call it again test2.txt. We could just say fp.write lines, and then we are just adding the list with the strings, and then fp.close. And if we execute that and then show us the content of test2.txt, then you see that it's exactly the 2 lines. So again, you can have a list of things and then you can just add it. You could also add, if you don't want to add, if you don't like to add here the new lines all the time, then what you can do instead is just use the join method, which you already know. You can specify a character here and join, and then specify a list of strings, and the list of strings which you specify would be joined by the character. And if you want to have a new line at the end of the second line, then of course you have to add also here the empty character, the empty string, and then it will be basically the empty string, which is nothing, and this one would be joined by the new line character. And then instead of write lines, you would just say, okay, that would be not the lines anymore, or let's do it differently. Let's first just specify lines, which is the list, and then here we would say write, and then we would say write \n.join lines, and then basically we are just joining them and then writing it out, and then again the content is unchanged. Basically that all works. That's also a strategy to do so. And there is also exactly this is the write lines method. So there are many ways how you can do that. For us, much more interesting than manipulating text-wise, which maybe we also sometimes do, but much more interesting for numerical purposes is to read and write numerical data. Okay, so basically some arrays, some numbers, and for that, let's create a file. Again, we will just go to Leafpad and we will just open a new file, test.dat. Just maybe a remark, if you make an ls, you see the test.dat file does not exist yet, but in Unix it's quite common. If you open a text editor with a file name which doesn't exist, then that file will be just created when you store it, right? So basically you can say leafpad test.dat. You see it opens an absolutely empty file, which means either this file didn't exist, or if it existed, it had no content. And now just let's make a matrix 1, 2, 3, 2, 4, 5, 6, for example. Okay, so it's not very complicated, just 6 numbers ordered in 2 rows, and then basically I just have stored that, and then changing back to the file IO worksheet. Just to be on the safe side, I will just show the content of the test.dat, and you see this is exactly what I entered. Now, how can I get it into Python, especially into an array, into a numerical array? And either you could just write it by hand, read the lines, split it, and then convert every number here into an integer or a float, and then create an array. But that's way too complicated, and NumPy has a very nice and very flexible routines for that. And those routines are basically the load.txt and save.txt routines. And the nice thing is with load.txt, you can just in one command read in a numerical array. And one thing which I want also to show you, that this can even fish out comments. So basically just let's edit test.dat once more, and here we are just writing some comment in the first line, which is not a numerical data, but you can use it to annotate your data. So add some comments. The main thing is it should start with a hash mark at the beginning, and so you see that the test.dat contains that line now, so the comment has been saved. And now basically because you want to use NumPy, we have to import it. I will import this np so that I don't have to type so much, and then if I say data is np.read load.txt it's called, and then I'm just specifying here the name of the file, which is test.dat. And then if we just print data, or if we just show data, you see that this is exactly the array which we had before. You see that it's that its type is an array, and for example its shape is exactly as was in the file, so 2 lines and 3 columns we had, and therefore the shape is 2 by 3. So it's very, very convenient. Equivalently convenient is the way how to write arrays, and this is a save.txt command, and with the save.txt you are specifying a file name and the data you want to write. So just to make the exercise which is on the slides, let's define data2, which should be an array. Let's say a floating point array with 1.0, 2.0 and 3.0, and then we just say okay, np.load.txt instead of load.txt is save.txt, and then you specify the file name, let's say test2.dat, and then we specify the name of the array we want to write out, and then that's it. And basically now if you just show the content of test2.dat, then it is nothing else, just what we have stored. It's a one-dimensional thing, and it becomes a column, and it will be basically stored column-wise. Okay. If you want to have everything in one row, then you have to make the array 2-dimensional, basically. So here we are just adding an extra layer, extra level in the list. And then you see it's in one row, and then if you have more than one rows, so basically that means an array which has more than one rows, then it will be done accordingly. So it's -1, -2, -3, and then you see that will be the next row. The nice thing is with numpy.load.txt and numpy.save.txt is that you don't have to open and close the files. So basically the only thing you are specifying is just the name of the file, and that's it. And the opening and the closing will be done automatically by the NumPy routine, which is very convenient, so you don't have to deal with that. The last thing I would like to mention for the file manipulation or file opening is the paths. So basically until now we always just specify the file name without any path in advance. That means that it takes the file from the current directory. But that's of course very often not the case. Sometimes you have to specify a directory which is somewhere else. So we could, for example, specify it explicitly and saying, okay, home Aradi work test to that, and so on and so on. That would work as well. And if you want to create the path from variables, so let's say you have dir name is equal /home/Aradi/work for whatever reason, say user, for example, user input, and then you have a file name which is test2.dat, and now you would like to compose, so you would like to, for example, say empty.save.txt, then there are many ways to combine them, and one way would do that, you just combine them basically with the slash file name, and that would be the name of the file. So basically the directory name plus a slash plus the file name, and then we are just adding data2. So that's possibility that would work, but this is not very nice because you never know whether the slash is the right character or not. So usually there's another, a more elegant way how you should join path names, and that you do by opening the os.path module, and then there is a special function which is called join, and then basically if I just copy this here again to repeat the example, and then here the nice thing would be that the path which you get is os.path.join, and you are basically join directory name and file name. And just so that we see what happens, I will also even print the path, and then you see, and here then instead of this I will just use the variable, the content of the variable path, and that works as well. And you see that it was automatically putting in the slash as it should. So basically if you want to join file paths together, please use the os.path.join function. Why? Because it could be that you are on a different machine, for example on Windows, and then basically the variable dir name contains a directory path, but not with slashes, but with backslashes, because in Windows it's exactly the opposite. And then you don't want to query when you join the two whether you on which platform you are, and os.path.join would automatically join them the right way, independent on which platform your program runs. So this is the preferred way of joining paths. Good. And with that, basically, I would like to close this session. I have shown you everything what I wanted to show you for the file I/O, and that's already enough to start with the basics which we will need. And thanks a lot for your attention. And in the next session, we will have a look at the basics of plotting. Thanks a lot. Take care, and hopefully see you soon.